Dear friends, Namaste and welcome to my channel. Today we are going to design reinforced concrete slab in CSI SAFE. This video includes the process to export slab data to SAFE file from ETABS and import the slab data to CSI SAFE. Also, we will learn how to define load combination, materials, slab sections, and check short-term deflection as well as long-term deflection of slab in software itself. At last, we will design the slab as per Indian Standard Code. After modeling and designing the building in ETABS, at first we have to run the model in order to export slab data including earthquake load. If earthquake load is not desired, we can export the model without analyzing it. If you have confusion or have no idea about designing building in ETABS, you can see my previous video about ETABS. Now let's check the difference between the exported model with or without analyzing it in ETABS. This model in ETABS, then we will be exporting this ground floor to SAFE, and after that we will export without analyzing, and we will see the difference in SAFE. That what parameter are exported and what are not exported after and before analyzing the model. The model has been analyzed. Now we will export the SAFE F2K file. We will be exporting ground floor. We will be exporting floor load only. As we are designing slab, we do not need the load from above, and we will click here and then click all load case, and also for load combination we will be clicking all load combination as I have defined default combination as per IS code for concrete slab design. Then we will click OK here, and then we will save this model as this name. I will be using model after analysis, and I will replace this file, and then I will open SAFE, and then I will import the SAFE file from the file that I have exported from ETABS. Then I will open this file, and we can neglect this part. I will check which load has been imported. We will be checking all loads. Dead load is self load, so value is not shown. Less than 3 here is used. Also another load, partition wall load, then other floor loads, other load live roof live. Now the main part I want to show this after analyzing the earthquake load are also imported in the form of point load. We can see EQX in all X direction, also EQY in Y direction. And now if we import the file after unlocking the model, now I'll export this model after unlocking its SAFE F2K file. I'll keep default this load case all, load combination all, and then export floor load only. As we have not analyzed, there are the only floor load is activated. Now I'll click OK and then save this file as model before analysis. I will replace this file. Now I will import model the file before analysis. Then I will check here, as here the earthquake load has not been imported, as we can see. You can see here, and other load are imported. Now in this video we will be designing the slab with earthquake load. For this I will import the file which I have previously exported from ETABS after analyzing. Now let's import the file that we have previously exported as model after analysis. Now at first here we have to uh, have knowledge about define. Here we are checking the material are also imported from etabs. We can see that from modify. Here it is the concrete M30, and another materials are Fe500, material 2 is Fe500, and then other material 3 is 27.5. I think this material is not used here. This material is also not used here. We can check our section. We can define material by, as we know, add new material, then we can change concrete and we put this value here. For a rebar we can click here and then we can input the value of the desired rebar material. Now we will be checking the slab property. As we have column here, the column strip material is defined here. Material 3 is clicked. I think this material 3 is of M27. Now I am changing this material 3 to material 1, as this is M30 concrete. Material 1, and then type will be stiff here. Thickness doesn't matter much more. Then I will be checking slab 125, material 1. This is okay, as this is M30 grade concrete. Slab 1 is not used, it is default, and this slab 175 is also not used. We can delete this part. Then we will be checking beam properties. We have this size that have been imported from etabs. We can check this. Rebar material M2, material 2 is Fe500, as we have already checked. Again, material 1 beam material is M30. For all we have that material. We can define beam properties by add new property and then providing necessary data here. We can provide concrete material here and rebar material here. Then we can define width here, top and bottom, and depth here, and we can keep we can put clear cover in this location. Generally we keep this clear cover 25 mm for beam. For 2 centroid we have to add rebar diameter plus diameter of strip. Now we will not be changing anything here, is we have imported from etabs. Now we can check this column property also. Material 4 is used. We can keep this material 1 as this material have been used. We may keep this default also, as this doesn't matter much more. Now we will be checking load pattern here. Load pattern have been exported from etabs. These all load pattern were used in etabs and that have been exported from there. We have no need to define any other. If any load combination has to be added, we can add here and add new load pattern and click here and write this value. I will be keeping this all default. And now the main part is about load combination. For load combination we will be using this default combination from etabs, as it is for design of slab from IS code. Now for long-term deflection and short-term deflection we have to define another load cases and load combination. We will be doing this later. as now we are talking about only the defined part. Now let's at first talk about long-term and short-term deflection part. As you know, there are basically three types of deflection. As we know, there are basically three type of deflection. First one is elastic deflection. It is for uncracked section. Second is immediate crack deflection. It is for crack section. And the third one is long-term crack deflection, which include creep and shrinkage deflection. The last two deflection are the non-linear case, and first one is linear case. For elastic and immediate crack deflection, the load combination will be dead load plus live load with factor 1. The dead load include all the dead loads like shelf weight, wall load, floor finish, and another type of dead load. And the live load includes all that load live loads, like live load greater than 3, less than 3, roof live load, whichever live load we have applied on ETAPS. Now for this we will be defining a load combination for elastic and immediate crack deflection. At first let us define load combination with dead load plus live load only. We may name it as elastic combination. For this we will add all the load, dead load with all for check for deflection. We will the earthquake load is not considered, it is considered for only design. Now let's add all the load here. Without, we are not adding earthquake case for deflection. Mainly we check for service load without lateral load. We will be cross checking 1 2 3 4 5 6 7 8. We will be cross checking either some load are missing or not. 1 2 3 4 5 6 7 8. Yes, we have. I think here are also 8 load pattern. Then we will click OK here. Then we will again, and for immediate crack section we will define this unload case. Here we will add new case, and then we will click here non-linear crack. We will name this load case as immediate crack, and then we will add all the loads without earthquake load. As I previously said, earthquake load will be only used for design combination, not for service combination. Well, then water tank. Then we will click OK here. Note that I have clicked here non-linear crack. Then we will be clicking OK here. Now for long-term crack deflection, the load combination is dead load plus 0.25 times live load. Here the long-term is in long-term crack deflection we consider shrinkage and creep. Here 25% of live load is considered for sustained load, but for deflection calculation we have to consider 100% live load. For this we have to define another load combination. For this I will create a new combination with dead load plus 0.25 live load for long term, and then I will add dead load plus live load for immediate crack and minus dead load plus 0.25 for immediate crack. From subtraction of this, I will get another 0.75 live load to aid here uh, of immediate crack, and um, this 25 will be for long term. Then it becomes a sustained load that here 100% live load is included. I want to clarify that here the live load here used is 100%, among which 25% is for long term and 75% is for immediate crack. Then it becomes sustained load. Now we will define the load combination for long term, and then this dead load plus 0.25 live load for immediate crack section, and this we have already defined. Now let's go to define load case. I have already defined immediate crack for dead load and live load with factor 1. Now I will be defining another live load. Let's copy this case and we will click this and we will rename this load case name as CSTAINED, and we will change the live load factor here 0.25, also in group live load 0.25, also in live less than greater than 3 also we may change 0.25. We are checking here nonlinear crack. Then we will define another load combination with, we may click add copy, and then we will define we will rename this load case name as long term crack. We will consider this long term crack here, and then this creep coefficient and shrinkage strength are for concrete. We may keep this default, and then we will be keeping this also here 0.25, 0.25 and 0.25 for live loads. Now okay, now we will define a load combination of long term deflection. Here we will be adding long term crack plus immediate crack minus immediate crack sustain. Here we will keep the factor minus, then we will click OK here. Now run the model. We may click here cracking analysis option. We may keep here rebar that we will provide after designing, or we may check click some base bar for here, but the better solution will be keeping this default value, and then we will keep this also default value, and then we will run the model. I'll save this here. It is analyzing. Then we will be checking 3 type of deflection. Here the model is analyzing. It is non-linear model. It will take a little bit more time than usual. Now to check deflection, I will go to display, show deform shape, and then I will check for at first load combination with elastic, that is not crack section. I will click here and see the maximum deflection is 6.53 for um, on crack section. That is uh, the maximum deflection is 6.53 mm for elastic combination, that is for um, on crack section. Here we can note that 6.53 is maximum displacement mm. We will then cross check with limiting value afterward. Then I will check for immediate crack deflection. I'll check this immediate crack from uh, load case immediate crack. Now here I can see maximum deflection is 21.76 mm for immediate. Here I can keep 21.76 mm for immediate crack deflection. Now I will check for long-term deflection from load combination. Here for long-term combination there is 38.37 deflection. 38.37 mm. Now the limiting value for this deflection, the permissible deflection for immediate deflection is span by 360, and for long term deflection it is span by 250. In our case the longer span is 7 meter. We can check this for 7 meter but for we can check for the slab in which maximum deflection has been occurred. This slab here there is the maximum deflection. We can check here from this part. We may check for 6.5 meter longer direction. Now I'll check 6500 divided by 360 is 18.05, and 6500 divided by 250 is 26 mm. Here we can see that permissible deflection for immediate deflection is 18 mm, and for long term it is 26 mm. Here the deflection has been occurred greater than permissible value, so I think the thickness is little bit insufficient, as our model failed in long-term deflection and immediate deflection. Now I will be increasing thickness of slab to 150, and I think this slab is little more critical. I will add a secondary beam here, and then also I will increase slab thickness of that part to 175, as there is a share of the void also here. So I will be increasing thickness of slab there. Then I will be adding a secondary beam from here to it straight line here. Then I will assign this slab as slab 175, then other slab will be 150, and then I will run the model. After revising the model and reanalyzing it, we will check the model After resizing the thickness of slab, we will check the deflection again. At first we will check immediate deflection. Here maximum value is 11.54. Here maximum value is 11.54 for immediate deflection, and then for long-term deflection we will be checking from here. It is 24, which is within permissible value. By this way we can check the deflection, elastic deflection, immediate crack deflection, and long-term deflection. Here we have permissible value. Now we can move further towards, also for individual slab we can check using their length for permissible value. If the span are different, in our case all the span along x-axis are same and y-axis are same, as we can see here. Now we move further towards designing the slab. To design, we have already defined the load combination. We may use this default combination of slab also, or we may use this default slab combination from tabs. For this I have to again run the model, as we have changed the design combination. Also we always have to check the preferences here. Here there is a in here we should have Indian code. We should change clear cover as per our requirement. Then we can click here. Again I have to analyze this. After changing anything from here, I think it has analyzed. Now for designing, we will just click here and click this show slab design. At first we have to add design strip that we have forgotten previously. To design a strip we will click here and then click a design strip. We will click include middle strip and then x direction and strip layer A and then auto. When we click this anti-form shape, the strip are can be seen here. Again we will design a strip here, and another will be y direction and strip layer B. Here strip has been added. Now we will see the result. To see the result, at first we have to know about this interface. This interface shows that layer A denotes the rebar of x direction, layer B denotes the rebar of y direction. We will click strip base, as we have added strip here. Then we will click impose minimum reinforcing. Here when we click in this, the result will be shown in I will be removing this horizon from clicking here. Now it is a little bit clear. At first, when I click this rebar intensity area per unit width, I can see the rebar area showing in mm square per meter. When I click this, the total, it will show total rebar area per unit per strip width. As we have clicked auto strip width, the better option would be this. And for to show number of bar of size, we may click here. There it will show the required number of bar uh, of diameter what we clicked here. And also in addition we may use base bar here, something in some spacing. I will keep this at 150. Then this will show the additional number of rebar required if this number bar is provided. I mean to say that when we provide this number of bar, and here it will show that additional number of bar required if the base bar is provided. This we can see like this here. This means here when we apply the bar 10 mm diameter with 150 mm spacing, the additional bar is required here. 30 number of additional bar are required in addition to this bar. Here we can also see there additional to this bar. Here we can see this. Now we can check the top bar, bottom bar, layer A, layer B from here. At first we may check layer A means x direction rebar for top bar. I am here it is showing if I provide top bar of 10 mm diameter with 150 mm spacing, the insufficient portion will be here. Here I will have to provide 30 number of 10 dia bar in this location. If I click this and none, the rebar intensity will be shown here. I have to provide 881 mm square per meter. This would be the easier. Also then if I have to check in layer B direction, the bar required bar will be shown here. We can also check by typical bar and this required additional rebar. Here we can see that number of additional bar required. We may change this bar diameter to 12 mm in order to reduce the additional bar required. Also we may reduce spacing also here. If I provide 12 mm diameter bar with 100 mm spacing, no additional bar are required. We may check this for bottom bar also. Layer A bottom bar, if I provide 10 mm bar in 100 mm spacing, no additional bar are required. If I provide this in 150 mm, then also it is okay. And for layer B, only this place I have to provide 4 number of 10 mm diameter bar. By this way we can design slab. For this area rebar intensity area per unit width, we have to calculate the spacing by clicking, by distributing this required bar. We may take maximum rebar area. For example, I will calculate the spacing of a place. Let's take that 326. Here I will calculate the spacing for you. If I have the capital area, if I have the area of rebar capital A equals to 326, then if I am providing the 10 mm diameter of bar 10 mm, then the number of bar required will be 326 divided by the pi into 10 square by 4, the result will be here. The number of rebar will be 4.15. When we round up this, it will be 5, and for spacing, one additional bar is required. Then the number of required bar is 6. Then the spacing of the bar per 1 meter will be 1000 divided by number. Then the 166 mm is required spacing. Then I may provide 150 mm spacing for this case. Similarly, we can uh, provide we can calculate other spacing too. By this way, we can design slab in SAFE. Here we have checked long-term deflection, short-term deflection, and we have uh, gained the knowledge about defining materials, slab properties, beam properties, also load patterns, uh, load case, and load combination too. Then we uh, may create a new model also here by uh, modeling techniques, which I have shown in the video of designing foundation by SAFE. In other video, you may uh, watch that video in order to get the knowledge about how the modeling technique and designing foundation also. And there will be the similar pattern of modeling and load applying load also. Thanks for watching this video. Please subscribe and click the bell icon if you think this video is useful for you. Thank you.